Okay, my friends, this is going to be good. They're talking about perovskite solar cells, which absorb a lot of energy that we were missing before, is what I'm believing. I haven't even watched this yet. You and I will watch this together. I want to comment on this. It's only 1.5 minutes long. National Science Foundation. We both pay for this, so we should be able to comment. Now, I hopefully will not be blocked, but I have found that I do get blocked quite frequently. Now, I would like to show my theory and my hopefulness that we could capture some of the electron showers, because that's what solar cells do, is they capture electron activity, which is the white part, the electron neutrino. The other part of that neutrino, which is the muon neutrino, can't get through, because the muon neutrino has all the weight and the electron neutrino has no weight and all of the energy. All right, so they're just exactly opposite. All of the energy and no weight whatsoever that I can find, the white one. And all of the weight and no energy other than movement, pushing energy, is the black one. So we want the white one and leave the black one. That's why when you fill up a battery full of electricity, it changes no weight whatsoever, because all you're adding is the white. And we can do that. We have separated that. Now, with these perovskites, we might be able to absorb just absolutely incredible amounts of energy. All right, I'm going to show you that we could take laser, shine it through a venturi, and keep the muons separated from the electron showers. Now, perovskites are going to be these multiple layers of transition metals, I believe, on a thin film. And if we can harvest all of those different frequencies and send them down through a photodiode, I should have put a gate here, and into a battery, we're golden. And you don't even have to put it into a battery, you could just use it on demand if you had enough of these little lasers inside of a little box like this. You just carry this around with you. You have any kind of outlet you want, any kind of AC, DC, 50, 60 cycle, whatever you want, USB, yada, 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 whatever you want. And it would just, and you should be able to get a much increased energy from the laser. Let's say the laser takes 5 watts of energy to use, 5 watts. What could we harvest over there from 5 watts starting? If we can go up to 10 watts, to 20 watts, to 50 watts, anything above 5 watts is just free. Because we take that 5 watts and you just go back in with that, and whatever's left over we use to run devices, do anything we want with it. If it's true what they say about electron showers, we could get hundreds of times more energy than we use over here. We could get 1,000 watts over here from 5 watts over here. Let's say we had 200 times, because they're talking in that range, 200 times more energy or weight or whatever. But whatever we can increase is free if we can do it. And that's all we want, is the white has no weight. That's the key. I can show you it has no weight, and we can separate it. And we use light, so we're not smashing huge, heavy, dangerous particles. Nobody gets hurt, and it's just light. All right, here's the key. We could put these little tiny lasers and receivers and put the harvester right there, the perovskites. This has no weight whatsoever, and it's tiny, tiny particles. This is a subatomic nuclear explosion. The black separates from the white, which is fission. It comes back together right here, which is fusion. We never get bigger than these particles right here. So we didn't hit anybody with a chunk like this and damage them. That's what happens when they do their damaging, smashing. They have to throw off particles that are like this size. That'll kill you. Ours are this size. That will not hurt you. That's just light. And it comes right back together instantaneously. So there's no damage. There's no damage to the environment. All we want is that white, and we're good to go. And that's the acceleration. That's not allowed by anything in science right now, in physics. Physics has to change completely. And it's fully understood. They just don't know what to do. And they cannot come around to talk to me about dipole electron flood theory, which works for everything. The particle was in this wave. The wave is a ball of energy, which has no mass. I cannot explain that. But the ball goes through the air, making this huge field because it pushes against everybody else's field. So they glow a little bit. This glows a lot. And the field keeps going forward, but the particle's way back here in the field. Particle-wave duality. That solves that. Acceleration of light, so that puts it to Einstein. Nothing he said was right. Not a single thing that I can find. You know, he's talking about relativity and time warps and gravity, this and that, and pulling everything. Well, yes, gravity is gravity, yes, absolutely. But it's because of this dark matter, because of these black particles. It has nothing to do with the white. The white is attracted desperately to the black, and then the black congeals in the center of the white. Okay, so here we are at the National Science Foundation. It's a government facility. And they're talking about perovskite solar cells. Now, I am going to leave a comment on here. I gave him a thumbs up, and my comment is, may I ask if anyone has seen Dipole Electron Flood theory? It might help to separate the electron showers using lasers and venturis. Then the perovskites can collect the energy. All right, so perovskites. These are new little mineral complexes that will absorb all the frequencies of light, I hope. That's what they're talking about. So I'm going to comment, and let's see if they allow this. I normally don't get able to comment in a lot of places. They don't like the way I say things. But all I'm trying to do is interact and show what I have compared to what they have. Now, this is only 1 minute and 30 seconds long. I haven't watched it. We're going to go through these things together, so let's go through it together. Now, I don't know if they'll let me put this up here or not. So sometimes they just block me, and a lot of it is public broadcasting. I can't do anything with that. A lot of things that are funded by the government, they only allow what they want to allow, and they won't allow me to comment. So let's see what happens here. But I'm going to let it play and see what it says.
With desirable optical, electronic, and quantum properties, holds promise for next-generation optoelectronics such as solar cells, LEDs, and sensors. Could a new study unlock ways to understand and control their performance? We'll explore in the U.S. National Science Foundation's Discovery Files. Perovskite materials are a promising family of crystalline compounds that can efficiently convert energy between electricity and light, showing great potential for LEDs, lasers, and solar cells. NSF-supported researchers from North Carolina State University have developed and demonstrated a technique for engineering a class of materials called layered hybrid perovskites, or LHPs, down to the atomic level, allowing for precise control over how the material converts electrical charge into light. The LHPs are made up of thin sheets of perovskite semiconductor material, separated from each other by thin organic spacer layers. The size and distribution of the layers determine how energy flows within the structure. The key to the new technique was to control the growth of nanoplatelets, individual sheets of perovskite that were not known to form during the creation of LHPs until now. This new technique opens the door for engineering highly efficient materials for a new generation of photonics and electronic devices, including printed LEDs and lasers. To hear more science and engineering news, including the researchers making it, subscribe to NSF's Discovery Files podcast.
All right, so that's enough of that. You see this? They call these Axions. This is something brand new. They come up with new names every day, and they're supposed to be inside of protons. And they say if these hypothetical axions, hypothetical elementary particles exist, if they exist, would clean up a problematic exemption to the rule involving what's known as CP symmetry. They got a whole bunch of things. They say these are rules, these are disaster, and they don't work. None of them work. You can speed up light, you can slow light down, you can do everything they said is just not correct. And when they smash their particles together, they just get debris, and they can't tell what they're getting. They just have a bunch of debris. Now, they say as a bonus, their existence, if they existed, which these are dipoles. I don't care what anybody says, an axion would have to be considered a dipole. If they exist, they could scrub out another perplexing mystery in science, the invisible added mass that helps galaxies, known as dark matter. Because that's the dark part attracted to the part we can see, the glowy part, which I have shown many, many times. We can see these particles now. It's not even hypothetical anymore. You see this? They don't know what axions are. Trust me, they do not know. Axions can resonantly convert into photons. Well, what does resonantly mean? They shake. They say they can, as they're bouncing, they can turn into photons. Well, we can see them, yes. And they do, they're right. Axions are not quite photons, but as they start really banging and banging and banging and banging, they do turn into photons. I don't disagree with that. Only they're talking about magneto-neutron stars and all this stuff. And in 2016, at MIT, they did see the axions using a strong magnetic field. It's only as strong as an MRI machine. And it showed a variation, slight wavering, linked to the mass of the axion, which is very, very small. The results in ensuing experiment published 2021 reported no evidence of axions in the mass range of this such and such range. Why do they have to have it in that mass range? Who cares? The mass range is only how fast it's going and what color light it is and what it bangs into. So I don't know how they did this, but there's no question whatsoever these particles exist, and they have a black and a white, and they can be separated. And I have shown this in dipole electron flood theory. And this is my model, theoretically, of a proton. And anytime you look at this, all you see is the glowy parts banging back at you. You say, whoa, whoa, whoa. So you shine something and it bounces back. And you say, well, I don't see any dark matter. There's no dark matter. But if you could get to the center of this, you would find there is dark matter. Just like this. If you took this, which is normally all this stuff is around it, the whole thing, and there's no atom that exists that doesn't have this configuration. Everything above an atom has this configuration. But if you could get inside, past the white particles, there's your dark matter in the center. All right, and all those white ones, they want so desperately to be attached to that they just cling to it like globs of them. Now, I don't know if they're equal to the number of these to these. I just don't know anymore because they have no weight. So the black particles have a certain number that they become stable, and these just gang around them. Now, some stability quantities in the center have a lot of excess electrons. There's ones that don't want to conduct electricity, and there's ones that do want to conduct electricity. That's why you have these different atoms, and they're different sizes, and they have different cores. And the core is what holds the electrons in. If the core is at a certain number, it will be, pretty stable with a bunch of electrons around it. But if it has too many or not enough of these dark particles, it will be an unstable configuration. And then it will want to bond, or want to conduct electricity, or it will want to explode, or it'll want to just stay stable. That's why you have these zones of stability. Some of them are very, very reactive in solutions and acids and salts. And some of them, they're inert. They just don't do anything. It depends on the configuration, literally, of the core. All right? This is all new. This is all new dipole electron flood theory. And it states, and I state, these are the only two particles that exist in the universe. Everything is made of light. Light is atomic vapor. All right? That was my statement in 1970. I have it written in my books from back then. I detail all my work throughout the years. The white is the glowy part that has all the energy and no mass. None. Almost none. As far as I can determine, none. This has all the weight and no energy to speak of unless it's being pushed. all right, banging into something. Yes, that'll knock a house down. This will just burn a house up. Won't even push the house. Nuclear bomb, these come out first because they always coat the black. The black is always inside. So it goes, and the whites go all the way out, and the house just burns up like this. And then a couple seconds later comes the black, and pow, the house goes flying and smashed to bits. That's how you know this has no weight, because it's the coating of the atomic bomb. And then what they do is they take and they force that in, and then it literally bounces back out. And then following it is the black material. And the denser you get that core, the more reactive it will become as it bounces back. Now, these are the only particles that exist, these two. And these are the configurations. Sometimes they can be energetic in different phases of colors. The two of them together make what's called a gluon, and then traditionally that would have been an electron, and you never knew that the dark part was there. Always it was just a white glowy part. But an electron really has two parts. And if you take these back to back, they make a photon. Just like it said before, that if you shake them, they can turn into photons. You shake that enough, they see them shaking, and then all of a sudden they see photons. I know this is new to everybody, so I just want to be sure you understand. I just told you, if you shake these axions, these dipole electrons, they will see them converting into photons. And yes, that is true yes, they do. The axions make up photons, so I don't disagree with that. All right, don't forget, this is CERN, Fermilab. All the big guys, they want to smash protons and neutrons together, which are particles like this. They don't realize it. And when they hit, they just, debris goes everywhere. We started with these particles right like this, these little bitty ones. So we can see what happened, first of all, which is excellent, because they can't see. All they see is the debris. X means that it could be this big, it could be that big, it could be this big, but I'm going to tell you what, when that hits you, you're in trouble. That's why they can only stay in these environments for certain periods of time. They have badges that say you're exposed too long, you're going to die. You know, they're working around this dangerous stuff. We started with light. Light is right here all the time. It doesn't kill you. It can hurt you, certainly. Heavy duty exposure to really intense light, yes, absolutely. Ultraviolet, way up in that range, yes, positively. However, what we're going to have is inside of a closed container that the particles never get out of there. They refuse instantaneously, and they're light. They're these particles. They wouldn't hurt you anyway unless you put your face right in the middle of them, and I don't think you're going to do that because you can't. It's impossible. It would be inside of that little box. Now, what happens in there? Well, here's what happens. These are the only two particles that exist, just like I told you. And this is from Fermilab. They're showing the glowy edge and the black, which is all the mass, no mass whatsoever, exactly what they say from Fermilab 10 years ago. Here's what we found in our light experiments. The identical same particles. No difference whatsoever. Only they started with things like this. So when they smashed them up, they just got debris. All they could see is, they saw them. They said, these are the smallest things we can find. That was it. And they were just lost after that because they didn't know where they came from. We know where they came from. They came from light, because this is light. That's a photon of light. There's no getting away from it. It's from the laser. And green is identical, only it's green. Now, as it comes through the air, it's banging into other particles that are in front of it. Have fields. They have their fields. This guy's got his field. Bam! Get out of my way. And this gets glowy, and then all of a sudden it'll go flip, and that one will come forward. It's called upspin and downspin, always polarized to the Earth. So they never twist this way. Well, actually, let me show you something. We found, I got to show you this, it's just unbelievable. They are always polarized towards the Earth. They never spin, they always spin like this direction as they move forward. All right, as you can see, look at this. This is the bottom particle. And they're always either up or they're down. It's one or the other. They're either upspin or downspin. Now, this one's downspin, and it's hitting these particles in front. I think you can see that. I know you can see that. Now, that makes it glow, and it will flip, and this one will come forward and start pulling out the energy. But it always does this. it never goes this way until this happened. Let me show you. And this proves a couple of things at one time about the speed of light, the intensity, the pressure of light, and why the perovskites are going to work well if they do a couple of things. All right, this is just, the green does exactly the same as the red. It accelerates and then it explodes at the Venturi. You get black and you get white, same thing. And when they come back together, and all of this would be green because it's a more energetic. Can I prove that? I absolutely can. And I can show you that the spin is always this way unless somebody pushes it and says, get out of the way. And then it will spin in a barrel roll. Never saw that before, and I don't think anybody ever seen it. All right, here's the green coming through. The green's a little faster, it's harder to see, and this cell phone wasn't as good as the Samsung, I don't think. Samsung Galaxy S3 from 2012. Fabulous. We've been doing this forever. Since about 2014, we've been seeing all this stuff. Now, this was from a guy, Fabien Boulet, over, I believe he's in France. And what he did was he took both lasers, a green and a red, at the same time through the same Venturi. And what is a Venturi? Well, it's just two pins sticking straight up in the air like that, but they're rounded. So when the light comes through that rounded Venturi, it has to force all its field into it, which makes it accelerate. That's what a Venturi is. So he had one above the other. All right, here's the red, and here's the green, obviously. This is, you can see it's like a dull looking color. And this is a brilliant looking color. Now, what happened with the red, instead of it just keeping going like this, it just says, get out of the way, I'm coming through. So the red was obviously much slower than the green, and the green just literally pushed it out of the way. And not only did it push it, it rolled it out of the way. This is literally unheard of, to see them rolling like this. They don't do that. They don't roll like that. The only reason that's happening is the green up above is coming in so forcefully that its field grabs that field and says, get out of the way, and it just slams it and spins it as it goes past it. You understand? The red would have been going, let's just keep going, having a nice day. Yep, everything would have been fine. And this thing comes and it goes boom, boom, and it knocks this thing spinning like this. Otherwise, it would just keep going like that. That is unknown territory. Unknown. Now, what happened to the green? Well, the green was so much more concussive. It reconcussed out here. The only reason we even see it here, I believe, is because it was interacting with a disturbance, which is the red. The red just caused a little disturbance, and it had to push it out of the way to continue, and it came out here. Now, if the green, if the red was never there, I think this is what we would have seen. They'd be so powerful coming through here, you wouldn't see them until they reconcussed out here by actually hitting other particles. Okay, my friends, here's my friend Chat once again talking about if we could get free energy. And it's basically saying no, it's just not feasible. Well, here's what it says. Hypothetical innovations. First of all, it basically goes out and says there's no way you can do this. However, hypothetically, methods to amplify energy through electron showers are possible, and here's the possibilities. Resonance systems, that's vibration. If electron showers could be induced in a material with specific resonance bounce, it might allow efficient capture of secondary energy, which is they bounce off particles. However, this would still require external energy source. That's what you do when you put in energy to anything. You put in energy, and then you can make the electrons go. So they're saying, well, it would just take a bunch of electricity or a bunch of energy to make energy, so that's a wash. Now, here's the next hypothetical thing they're talking about, quantum effects. Here's where I come in. If novel, new quantum effects could be harnessed, such as the Venturi, they're talking about in a vacuum. We don't need a vacuum. There might be a way to extract additional energy indirectly. Extract additional energy indirectly. However, this is purely speculative and not supported by current physics. No, because they won't look at dipole electron flood theory or the Venturi. No, because all we didn't add any energy at all. We just let it break itself apart. That's the beauty of this whole thing. There's no additional energy. It just doesn't require anything. The conclusion: without additional external energy, no, we didn't need it. It's not feasible to obtain free energy from electron showers due to constraints imposed by fundamental physics laws. No, there is no fundamental physics laws anymore. However, advancements in energy capture quantum technology could provide innovative ways to utilize such phenomena and more efficiently in the future. Well, quantum just means smaller than atoms. It's the pieces that make up atoms is the quantum. That's where I work. I work with light. Light is basically the smallest stable particle there is. It's stable, but it's light. It's just everywhere. And it only consists of two dipoles. Back to back like that, up and down. Simple as that. So they're saying, no, you have to add extra energy. No, you don't. You have to extract the white from the black. That's all you're doing when you create energy. They have to understand the white has no mass, and when you put that into a battery, you don't increase the mass of the battery. So all you're doing is moving the white into the battery, and we can separate the white very easily with no additional energy. So we are doing all of that work for free. Okay, my friends, with electron flood theory, I challenge this statement. I asked why a battery doesn't gain weight when it charges. It doesn't gain any weight at all. It charges, discharges, never changes weight. Why? You got all kind of energy. Now they're saying all it does is move particles differently inside the same material. Listen to what it says carefully. In a battery, charging rearranges electrons and ions. It just rearranges them within the battery materials. This involves a change in chemical potential energy, a change in the chemistry. But the total number of atoms and fundamental particles remains unchanged. Right? There is no macroscopic addition of material that would register as a weight increase. So they say, well, nothing's going in it. Well, what gives us the energy? Where did the energy come from? They're saying, oh, it just rearranges the molecules. Yeah, show me how that works, because it doesn't. It's not that. What it's doing is it's absorbing extra white particles, which have been disassociated from the black particles, and they want to get back to the black particles. That's all it is. The white has no weight whatsoever. They just want to get back to the black. That's why it doesn't add any weight. We push the white into the battery. That's all. The black had to stay back. When you do generation and you do a generator, that's what happens. It rips the white away from the black and pushes it through diodes, photodiodes, and so forth, and into the battery. Okay, I keep getting interrupted, but I believe I showed you about the perovskites. Now, they're made up of light thin sheets of these perovskites, and I think they're in layers. And I've been saying this for years. What they need to do is put different transition metals. Where's my thing? Here it is, right here. You see these different colors? These are basically the different colors of transition metals. And I think if you had these in layers rather than just the silicon, I don't know what they have some certain chemistry to these solar cells, and they're picking up these high energy frequencies. But there's a lot of low energy frequencies in there too. White light has everything. It has all the white all the way up to the top. And when I say white light, I'm talking white light on whiteness. Look at that. It come in red. You can't even see it. It came in. You would never see this except for this acceleration factor. And at that point, it literally exploded and split here. The black separated from the white, and it came back here. That's fission and that's fusion. It's as simple as that. It's subatomic. We're not breaking huge, gigantic particles like they do at CERN and Fermilab. That's fission, yeah. They smash it to bits. And then they all come back together, but some of them don't come back together right away, and that's called nuclear radiation. And they, pew, 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 they give off these particles every now and then. They just spit them out. And that's what this thing over here detects is nuclear radiation, how many microsieverts you're picking up. And there's a certain number every year, you know, they say claim it's safe. I don't know. Who knows? But the people that work at CERN and all those places, they got to be careful of this stuff. They're all they have to wear badges, and they're always being irradiated because they're working with these kind of particles. We're not doing that. We're working with these kind of particles right here. We're working with the bits and pieces that they see and they have no clue about. We don't ever get up to this size. We're down here with photons and smaller. We never started with this. That's why we're way ahead of them. You see this? These are transition metals. They're in here, right in here, in this area here. And they are charged. They're charged. They can receive and give up electrons, basically. They're charged particles. And these are what you use in your blood. They're transition metals in your blood. They do nucleophilic substitution. They come through your body and they give up stuff and take stuff in, back and forth. And these what they call ligands. They're these particles that surround the metal core. This is the metal core. You see +2, 5, 6, 3, 7, all kinds of stuff. And those are the attachments to all these extra particles. They go through your body and say, anybody need any of these +2s, +3s? You got any give me 2 5s, I'll take 2 jacks and a king of spades, you know, that type of thing. So it goes through your body and it distributes all this stuff, comes back and loads it back up again. That's your blood. That's what's in your blood. Now, big deal, Roger. Why are you telling me this? Well, here's the deal. Each one of these has a different potential to absorb a certain frequency. All right, if it's light, you got a million zillion frequencies. All right, this is what light is. And they're not flappy waves either. They're spinny waves. All right, they spin. Light spins just like this. It doesn't flap in a wave like that. If you looked at it from the side, you could see that as a wave. And the faster it spins, the more energy it has because it's... And when it's real, it's just not as much energy. And I showed that with the red and the green lasers. Now, what am I getting at? If I hit this thing, and this thing is like this, it's going to go right through almost anything except something maybe that's blue, because blue is down a really high energy stuff. So it'll push back hard, bang, and that'll shoot some electrons through. But normally it'll go past through almost anything. Now if it's red, it's going to bang right into the first red thing it sees. Or into something. Red is just really weak, so it's going to become and there's going to be all kinds of things in front of it, and it's going to pretty much stop at the first layer of perovskite. Whatever that is, I don't know. Right now, I don't know which one of these is going to absorb what layer. But these are the layers that I am showing in my little sketch I did years ago. These different layers. You see the colors? I don't know if those are the right sequences of colors, but anyway. So the laser shoots through, and all it does, all by itself, we don't do anything. We don't add any energy whatsoever. It just says, black guys, stay out. You can't come through. And the white ones come through, and they would be absorbed in these layers of these transition metals, which I believe is what they're going to be doing with perovskites. And now how would I do it if it was up to me? I'd take a paint sprayer. And I'd spray the first layer, then the second layer, then the third, and the fourth, and the fifth, and all the way up to transition. And you could probably do it. All of these have different absorption frequencies. All right, and if you can get them to absorb all those white particles, and then just feed them through what they call a bus, is just a big heavy duty wire, and it'll run down into your battery or go right to your car wheels or whatever. And you can take something like this and walk around with it. I'm telling you right now, because this is as sophisticated as it gets. You've got a couple of little regulator devices down in here to take the raw energy and convert it into, put it into your batteries, and then after that you regulate it to whatever you want. Very simple. I mean, all that stuff, everything here exists off the shelf today. And then you run through whatever your device, and it comes back around again. All the white wants to do is get back to the black. This is called a floating ground. The white just desperately wants to get back to this black. So it goes right through the battery, up through your motors and whatever it is, or even you. It'll go right through you and burn you up to get through back. It just wants to. The white is so desperately attracted to the black, it's unbelievable. And that's what gravity is. Gravity is the Earth being, as a matter of fact, here's gravity right there. The Russians did this in 2015, and I contacted them about this. And at the same time, I contacted Don Lincoln. I copied him in on when I was talking to the Russians. I said, we found the particles can separate from the white particles, and I said a couple other things. Nothing too sophisticated, just so that I could see if I could establish some kind of relationship. Well, Don was pretty obnoxious right from the get-go, and he responded, but like I say, it wasn't nice. Now, anyway, this is a black hole. It's a black hole, and the reason you can't see anything here is they're shining light in here, and only the particles that have glowy parts to them, like these, bounce back. A black hole, the dark particles, they don't absorb, they don't emit, and they don't reflect. So it doesn't reflect back the light we're sending in like these do. It doesn't emit light, and it doesn't absorb light. Well, where does that light go? It actually ends up going around the sphere. And but at any rate, this is what happens, and you see it's a little bit flattened out. That's because they're in space, still under gravity a little bit. But if this was on Earth, you'd never see this. You'd see a line of white, which is what you'd see if you could see all the particles that are attached to the Earth. There are all these white particles. The Earth is a dark mass. We're standing on dark matter right now. The white has no mass whatsoever. It doesn't have any mass. You're not standing on a white. You're not standing on a white, you're standing on a black. The Earth, anything that is a big source of gravity, is literally mostly dark matter. And the white is pulled down to it. That's what gravity is. The bigger the dark matter gets, the harder the white gets pulled down to it. This is extremely attractive to the white. This doesn't go to the white comes to this, and it forces around it and creates these balls of blackness. That's a black hole. And this was 2015 or 2014, it was a long time ago. And since then, Don, I have never gotten along.